And now we get to the last quantifier that we are going to consider, which is going to be the uniqueness quantifier. So let's jump right into the definition. So this looks very similar to our existential quantifier, but you notice that I've added this little exclamation point right next to this backwards E right here. And so the way that we would read this symbol right here is there exists a unique, or there exists only one. X such that P of X. So by this bunch of symbols, we mean the proposition there is one and only one value of X that makes your propositional function P of X true over here. So it's similar to the existential quantifier, but with the added restriction that there's one and only one value that makes your propositional function true. So as an example, if we were to look at the propositional function, x plus 2 equals 0. Then if we were to consider this thing with our domain all real numbers, again here using this notation for all real numbers, and we are to consider this uniqueness quantifier, is this proposition true or false? Does there exist a unique real number such that x plus 2 equals 0? Well, it's not actually too difficult to see that this thing here is true, because indeed just basic algebra tells us that if x plus 2 equals 0, then that means that we need to have x be negative 2, right? So here I have a value, and let's go ahead and see, does it actually make my propositional function true? Yes, indeed, it is true. And in fact, it is the only value of x, the only real number that will satisfy this equation, x plus 2 equals 0. And you can show that using simple algebra. So here, this existential quantifier, this uniqueness quantifier right here, there exists a unique x. That proposition is true for this particular propositional function right here. If you wanted to make a comparison with our other quantifiers that we've been looking at, you can try and take a guess at this. Well, with our domain R, is it true that all values of x plus 2 equals 0? Well, definitely not. This is false, and our counterexample would be anything besides x equals negative 2. Like x equals 4. So if we were to plug 4 into this propositional function right here, 4 plus 2 equals 0, nope, that's a false statement. Therefore, since we have found a counterexample, this universal quantifier statement here is false. Also in comparison, if we were to drop the uniqueness, so here I drop the uniqueness, so instead of using the uniqueness quantifier, I'm just using the existence quantifier right here. This thing is a true statement, because here this needs just at least one value. And we've already found at least one value. We already found one value here that makes it true. So that is our uniqueness quantifier. Let's go ahead and consider another example. And revisit x squared greater than x right here. We already saw that the universal quantifier of this statement right here is false. And we already saw that the existential quantifier of this thing is true, right? So the counterexample to this one, we saw a half, and the one value that we could demonstrate that made this thing, this propositional function true, we used, I think, x equals 4, which made this thing true, so therefore the existential quantifier. Well, what about the uniqueness quantifier? What about there exists a unique real number such that x squared is greater than x? So here again, in my context, I'm assuming that my domain is all real numbers. Well, to try to show that this thing is either true or false, I have an inkling that this thing is going to be false right here. So I'm going to claim that that's a false statement. So to show that it's a false statement, I would have to show one of two things. Well, by definition, it says there is only one value of x that makes our propositional function here true. So I would either have to show that there is no value of x, such that q of x is true, or I would have to show that there's more than one value of x such that q of x is true, because our uniqueness quantifier says there needs to be one and only one. So I could either show that there are none or there's more than one. And in this case, I can use b right here to show that this thing is false. And so if I consider and there we go. I have demonstrated two values that make my propositional function right here true. So therefore, there exists a unique real number such that q of x, that proposition right there, is false. There's more than one value in my domain that would make my propositional function here true. So there we go. Those are our three main quantifiers. We have universal, existential, and uniqueness quantifiers. Those are going to be the main ones that we are going to be considering.